Hello students, welcome back to this lecture, one quadratic equation. So in this lecture, we'll continue previous year questions, one quadratic equations. Okay, so in our previous lecture, we have started previous year questions, one quadratic equations. Okay, so in this lecture is basically continuation of the previous year questions, one quadratic equations. So let's get started. So in our previous lecture, there we have basically discussed about question number 1, 2, 3, 4, 5, 6, 7. Okay. So there we have discussed question number 1 to question number 7. In this lecture, we will discuss question number 8. Okay. So here in this question, it's said to us if the quadratic equation px square minus 2 times root 5 px plus 15 is equal to 0 has two equal roots, then find the value of p. Okay, so this equation, for this quadratic equation, this equation has two equal roots. Okay, and you have studied in your previous lecture, if the quadratic equation has two distinct real roots, then the discriminant b square minus 4ac, this is greater than 0. And if a quadratic equation has equal roots, two equal roots, then the discriminant b square minus 4ac, this is equal to 0. Okay, and when b square minus 4ac this is less than 0, then the quadratic equation ax square plus bx plus c equal to 0 has no real roots. Okay, so here this question basically is based one nature of the roots for quadratic equations. Okay, and we here basically for this condition, two equal roots, we will use the discriminant equal to 0. Okay, and from that equation we will find the value of p. So let's solve this problem. So we have given quadratic equation is px square minus 2 times root 5 px plus 15 is equal to 0. Okay, so now if we compare this equation with the standard equation of a quadratic equation, that is ax square plus bx plus c is equal to 0. Okay, so if we compare this equation with the standard equation of the quadratic equation, then you will get the values of a, b and c. So here the value of a is basically equal to p, and the value of b is equal to minus 2 times root 5 p, and the value of c is equal to 15. Okay, so now for real equal roots, discriminant is equal to 0. Okay, and we know for a quadratic equations ax square plus bx plus c is equal to 0, the discriminant is equal to b square minus 4ac. Okay, and here we already get the values of a, b and c. Now if we put all the values of a, b and c, then we'll get the value of discriminant. Okay, and if the discriminant equate to 0, then we'll get two equal roots. Okay, for two equal roots, for two real equal roots, discriminant is equal to 0. Okay, so therefore b square minus 4ac, this is equal to 0. Okay, and the value of b is equal to minus 2 times root 5 p, and the value of a is basically equal to p, and the value of c is equal to 15. Okay, so now if we put the values of b, a and c, then we get this equation: minus 2 times root 5 p whole square minus 4p times 15 is equal to 0. Okay, so now if you simplify this equation, okay, then you will get 20p square minus 60p, this is equal to 0. Okay, so 20p square minus 60p, this is equal to 0. This is basically we get by using the condition for equal to real equal roots. Okay, that case the discriminant equal to 0, b square minus 4ac, this is equal to 0. Okay, and after after putting the values of a, b and c, we get this equation minus 2 times root 5 p whole square minus 4 times p times 15, this is equal to 0. Okay, and after simplifying we get this equation 20p square minus 60p, this is equal to 0. Okay, so therefore 20, if we common out 20p, then we get this equation 20p times p minus 3 is equal to 0. Okay, so here 20p times p minus 3, this is equal to 0. So it implies either p is equal to 3, p is equal to 0 or p minus 3 is equal to 0. Okay, so when p minus 3 is equal to 0, then p is equal to 3. Okay, and when p is p is equal to 0. Okay, so p is equal to 3 or p is equal to 0. But p is equal to 0, this is not possible. Why this is not possible? Since if p is equal to 0, then the coefficient of x square, x are basically 0. Okay, so this equation, the given equation, will not be a quadratic equation. Okay, so here p is equal to 0, this value we will neglect it. Okay, and here we only value of p can be 3, therefore p is equal to 3. So the given quadratic equation has 2 equal roots, then the value of p is equal to 3. Okay, now let us move to question number 9. So in question number 9, here we have given this quadratic equation x square minus 2kx minus 6, this is equal to 0. Okay, and here we have given this information x minus 3, this is one root of the quadratic equation x square minus 2kx minus 6 is equal to 0. Okay, so here in this equation you can see k is a constant, k is a real number, okay, and which is actually constant, and here for this equation, here the value of k is unknown. Okay, so in this problem basically we have to find the value of k. So if we substitute the value of x is equal to 3 in this equation, and if we simplify that equation after substituting the value of x equal to 3, then we will get the value of k. Okay, so let us solve. So since x is equal to 3 is one root of this equation, okay, and we know x is equal to alpha, this is called root of the quadratic equations ax square plus bx plus c is equal to 0 if alpha satisfies ax square plus bx plus c is equal to 0. That means a alpha square plus b alpha plus c is equal to 0. Okay, so if we use this concept, then here in this question we have given x minus 3 is one root of this quadratic equation. Okay, so of this quadratic equation, so here since x is equal to 3 is one root of the quadratic equation x square minus 2kx minus 6 is equal to 0. Okay, so now x is equal to 3, this value satisfies the given quadratic equation. Okay, so now if we substitute the value of x equal to 3 in the given quadratic equation, then we get 3 square minus 2k times 3 minus 6 is equal to 0. Okay, and it implies 9 minus 6k minus 6 is equal to 0, and it implies 3 minus 6k, this is equal to 0, and it implies 3 is equal to 6k. Okay, and it implies k is equal to 3 by 6, k is equal to 3 by 6, that is equal to 1 by 2. Okay, so here the value of k is equal to 1 by 2. Since x minus 3 is one of the roots of this quadratic equation, then x minus 3 satisfies this quadratic equation, then after substitute the value of x is equal to 3, we get the value of k, this is equal to 1 by 2. Okay, so therefore the value of k is equal to 1 by 2. Okay students, now let us move to question number 10. So in this question here we have to find the values of k, for what the roots of the given equation x square plus 4x plus k is equal to 0 are real. Okay, so here we have to find the value of k. So student, first think about this problem. So how to approach this problem? Think about this. Okay, and which concept will use for solving this problem? That will have to that will have to remember. Okay, for which concept, for using what concept this problem will solve, that we have to keep on our mind. Okay, so here we have to find the values of k. So here let us solve this problem. So we have given this quadratic equation, x square plus 4x plus k is equal to 0. And since roots of given equation are real, and we know for a quadratic equation ax square plus bx plus c is equal to 0, this quadratic equation has two distinct real roots if the discriminant b square minus 4ac, this is strictly greater than 0. Okay, and when two real equal roots, it has two real equal roots if the discriminant b square minus 4ac, this is equal to 0. Okay, so for getting roots of the given equation are real, the discriminant should be greater than equal to 0. Okay, so here for this quadratic equation, if we compare this quadratic equation with the standard equation of the quadratic equation, that is ax square plus bx plus c is equal to 0. Okay, so then you will get the values of a, b and c. Okay, so now first compare this equation with the equation ax square plus bx plus c is equal to 0. Okay, then here you will get the value of a, this is equal to 1, and value of b, this is equal to 4, and the value of c is equal to k. Okay, and we know the discriminant for a quadratic equation ax square plus bx plus c is equal to 0 is b square minus 4ac. Okay, and here we get the values of a, b and c. Now if we put the values of a, b and c in the expression b square minus 4ac, then we'll get the discriminant d, this is equal to 4 square minus 4 times 1 times k. Okay, and this is greater than equal to 0. Okay, and it implies 16 minus 4k, this is greater than equal to 0, and it implies minus 4k, this is greater than equal to minus 16, and it implies k is less than equal to 4. So therefore the k has all real values less than equal to 4. Okay, so it has all real values less than equal to 4. That means k may be 1, 2, 3, or minus 1, minus 2, minus 3, and also irrationals, all numbers. Okay, that are all less than equal to 4. So here the values of k, that is less than equal to 4, the roots of the equation x square plus 4x plus k is equal to 0 are real. Okay, so now let us move to question number 11. So in question number 11, here we have to find the nature of the roots of the quadratic equation 4x square minus 5x minus 1 is equal to 0. Okay, so first of all, you have to compare this quadratic equation with the standard equations ax square plus bx plus c is equal to 0. Okay, so if we compare this equation with the standard equation ax square plus bx plus c is equal to 0, then we will get the values of a, b and c. Okay, so if we compare this equation, then we get the value of a is 4, and the value of b is minus 5, and the value of c is equal to minus 1. Okay, so let us solve this problem. So here the value of a is 4, b is minus 5, and c is equal to minus 1. And we know for a quadratic equation ax square plus bx plus c is equal to 0, the discriminant d is equal to b square minus 4ac. Okay, now if we put the values of a, b and c, then we'll get the value of d. So here the value of d is equal to b square, that is minus 5 square minus 4 times 4 times minus 1, that is equal to 25 plus 16, and this is equal to 41. So here you can see the discriminant D is equal to 41 and this value is positive. Okay, so this is positive, so the discriminant is greater than 0, and we know a quadratic equation has two distinct real roots if the discriminant greater than 0. So here we get the discriminant D is greater than 0. Okay, so therefore the given equation has real and distinct roots. Okay, so the given equation has real and distinct roots. Now let us move to question number 12. So in question number 12, here you have to solve the quadratic equation x square plus 2 times root 2x minus 6 is equal to 0 for x. Okay, so for solving this quadratic equation, we can use factorization method, or we can use quadratic formula. Okay, so let us solve this problem. So we have given this quadratic equation x square plus 2 times root 2x minus 6 is equal to 0. Okay, and now if you split the middle terms, 2 times root 2x as 3 times root 2x minus root 2x. Okay, so then therefore x square plus 3 times root 2x minus root 2x minus 6 is equal to 0. Okay, and it implies x times x plus 3 times root 2 minus root 2 times x plus 3 times root 2, this is equal to 0. And it implies x plus 3 times root 2 times x minus root 2, this is equal to 0. Okay, and it implies either x plus 3 times root 2 this is equal to 0, or x minus root 2 is equal to 0. Okay, and here we get the values of x is equal to minus 3 times root 2 and root 2. Okay, so the roots of this quadratic equation are minus 3 times root 2 and root 2. Okay, and now let us solve this problem, question number 13. So here we have to find the discriminant of the quadratic equation 3x square minus 2x plus 1 by 3, this is equal to 0, and hence find the nature of its roots. Okay, so here we have given this quadratic equation, and here we have to basically find first the discriminant of this quadratic equations, and then we have to find the nature of its roots. Okay, so let us solve this problem. So discriminant D of a quadratic equation x square plus bx plus c is equal to 0 is b square minus 4ac. Okay, so this is the discriminant of the quadratic equation ax square plus bx plus c is equal to 0. And now for discriminant for 3x square minus 2x plus 1 by 3 is equal to 0 is b is equal to minus 2 square minus 4 times 3 times 1 by 3, and if we calculate it, then it is basically equal to 0. Okay, so hence the here discriminant is equal to 0, and we know a quadratic equation ax square plus bx plus c is equal to 0 has two equal roots. It has two real equal roots if the discriminant equal to 0. Okay, so hence the roots of this quadratic equation are real and equal. Okay, now let us move to question number 14. So in question number 14, here we have to find the roots of the quadratic equation x square minus x minus 2 is equal to 0. Okay, so for finding the roots of this quadratic equation, we can factorize this quadratic polynomial x square minus x minus 2 by using splitting the middle terms. Okay, this is one way, and another way is you can directly use the quadratic formula. Okay, so now let us solve this problem. So here first we will use factorization method. Okay, so here we can split the middle term minus x as minus 2x plus x. Okay, so x square minus x minus 2 is equal to 0. This can be written as x square minus 2x plus x minus 2 is equal to 0. Okay, and it implies x times x minus 2 plus 1 times x minus 2, this is equal to 0, and it implies x minus 2 times x plus 1, this is equal to 0. Okay, and it implies either x minus 2 is equal to 0 or x plus 1 is equal to 0. Okay, but so it implies x equal to 2 or x equal to minus 1. So hence the roots are 2 and minus 1. So here we can also use the quadratic formula. So we know quadratic formula, x is equal to minus b plus minus root over b square minus 4ac divided by 2a. Okay, so here we have given this quadratic equation, x square minus x minus 2. Okay, and if we compare this equation, with the quadratic equation ax square plus bx plus c is equal to 0, okay, then here the value of a is 1, the value of b is equal to minus 1, and the value of c is equal to minus 2. Okay, and now you can put the values of a, b and c. Okay, so therefore x is equal to minus of minus 1 plus minus root over minus 1 square minus 4 times 1 times minus 2 and divided by 2 times 1, and this is equal to 1 plus minus root over 1 plus 8 divided by 2, and this is equal to 1 plus minus 3 by 2, and therefore x is equal to 2 and or x equal to minus 1. Okay, so the roots of this quadratic equation are minus 1 and 2. Okay, so the roots are 2 and minus 1. Now let us move to question number 15. So here in this question, find the sum and product of the roots of the quadratic equation 2x square minus 9x plus 4 is equal to 0. Okay, so here we have given this quadratic equation and we have to find the sum and product of the roots of this quadratic equation. Okay, so for ax square plus bx plus c is equal to 0, sum of roots is equal to the minus of coefficient of x divided by coefficient of x square. Okay, so sum of roots, this is equal to minus b upon a, and product of roots, this is equal to constant term divided by coefficient of x square. Okay, so we have studied the relationships between zeros of a quadratic polynomial and its coefficients. Okay, and from that topic we get this relation, sum of roots, sum of zeros, that is sum of zeros equal to minus of coefficient of x by coefficient of x square. Okay, and product of zeros equal to constant term by coefficient of x square. Okay, so here we know the roots of the quadratic equations and the zeros of the quadratic polynomial are basically same. Okay, so sum of for this case, sum of roots, this is equal to minus coefficient of x divided by coefficient of x square, and product of roots, this is equal to constant term by coefficient of x square. Okay, so therefore sum of roots of this quadratic equation, for quadratic equation 2x square minus 9x plus 4 is equal to 0, sum of roots, this is equal to minus of minus 9 divided by 2, and this is equal to 9 by 2. Okay, and product of roots, this is equal to 4 by 2 and this is equal to 2 basically. Okay, so sum of roots of this given quadratic equation is 9 by 2 and product of roots of this quadratic equation is 2. Okay, so here we use the concept relationship between roots of a quadratic equation and its coefficients. Okay, so in this lecture we have covered previous year questions. Okay, so I stop here this lecture. Thank you very much to all of you.